Being what Felix was explaining earlier, which is this thing called an agent loop, which is how like an agent interacts with like people and how in its environment. And people like this benchathon is kind of more so for everyone to think about cool benchmarks that you guys can create or environments for LLMs to interact with. I can guarantee that like half of all the, not half, but like a vast majority of LLM papers that get submitted to like all these NLP conferences, also ML conferences, a lot of them are called benchmark papers because they're doing exactly what you guys will be doing this weekend, which is building a benchmark, and then these guys, bench some models and then write a paper about it. I think it's a little lazy just to build a benchmark for it, but they're still very important, and people have been building it for a long time. But yeah, feel free to stop me at any point to ask questions, but I'll just kind of run through a summary of what they just showed on the screen. So basically, all the agent loop is you have some M, you have some LLM, and people call this the LLM agent, whatever. The M outputs something called a state, and the LLM basically looks at the state, it makes some decision, and then it produces an action. And this action is basically consumed by the environment. The environment's going to look at it and generate a new state. For those of you who've taken 312 or any sort of statistics, you can think of this as just a Markov decision process where you have one node and then you have an action that goes to the second node, yada yada, and forever and ever on. Is there any questions on that? Cool. So basically what you guys will be doing is you guys will be building the N, and we've taken care of this LLM portion. When you guys submit your N and you run a bench, we on our platform will run Claude, ChatGPT, and Gemini to basically play around with your N. And it will produce some results that we will then share with you, or the platform will share with you, and then you can make a UI and present it. And so yeah, almost every single LLM wrapper YC company basically just does this. This is it. And there was this entire paper written about this. You guys can search it up. It's basically some guy or some PhD was like, okay, we're gonna create this principle called React, which is just not the UI framework, but basically it's just an LLM make some action, interacts with the environment, get some state out, and it's done. Thank you. Yeah, and there's another paper you guys can search up. It came out in 2023 called Voyager. And basically, all they did was they taught ChatGPT to play Minecraft. And when I say they taught ChatGPT to play Minecraft, all they did was create an N, which was Minecraft. The N would output some frame of the game. The ChatGPT would look at that frame, generate some code, right? That would be the action, execute that code, where the N would execute that code, and then on and on until they beat the Ender Dragon or something. So yeah, we only expect you guys to build the N because what people like Meta tend to do is they take M's, they basically train their AIs off of it, and they cheat a little. Every big lab does this, by the way. They tweak the numbers a little so their models look a little better than before. It's called benchmaxing.
Contamination.
That too, yeah.
Yeah, they can train on very similar derivative tasks of what the benchmark's supposed to achieve. For example, that SweetBench one, part of the reasons the scores have gone up is because we know where to look in terms of how to train the models. So it's called contamination. They try to avoid it, and that's a good hallmark of a good bench is that it's hard to contaminate. It's hard to train against that data before it's been exposed to the questions anew.
Yeah. So basically, the reason why we built a separate LLM platform is instead of letting you guys do the benchmarking, we'll handle that, and that way we can claim that the benchmarks, the benchmarks that we do obtain from the platform are legit and no one is cheating off of it. Not that I would assume anyone here would cheat, but just for the sake of when we present this to some larger companies. Yeah. I guess the final thing about why this could be hard is this all seems very simple, but the state and action is actually something that you guys will have to figure out yourself. state and action both have a lot of edge cases, and you can imagine that like both of them, they could be I don't know if you guys know the term, but discrete and continuous. And so for an interactive example, I'll guide you guys through thinking about how to build environments for 3 different environments. And the first one we'll do together is tic-tac-toe. Specifically for tic-tac-toe, does anyone want to like tell me what the state would likely be for tic-tac-toe? Yeah.
Like a board?
Exactly. Yeah. Perfect. It would be the board. And for a bonus question, you want to tell me what you think the state space would be for this board? The state space is like the number of possible states that could occur. Yes.
Something to the 9, but
Is it 3 to 9?
no, it's not. 3 to 9 is too many.
Yeah.
It's 2 to the power 9.
To the power of 9.
But it shouldn't be the end state because there's only like half of that. So
Yes.
no.
Wait. Why 9 factorial? Right, but every space can only be x, o, and nothing.
No, I think it's 3 to 9.
You have 2 choices for every square.
Yeah, but it can be unfilled, so it's 3 to 9.
Yeah.
No, but
Yes,
there's
yeah,
you can only have half of the board's
No,
one.
just say 3 to the 9, it's easier.
Are you saying valid state spaces or invalid
Valid.
state spaces?
Oh, but
Oh, they have to be valid. We're saying
okay,
valid.
Yeah,
that's
that is
essentially
way
what
less.
it is.
That's
Yeah.
much harder to compute.
Yeah.
Yeah, like if you have to account for like
Could just roughly say 3 to the 8.
once matching, it's much harder to do.
Okay.
You need like a recurrence equation to solve that. It's not possible to just
Let's just say everyone is acting validly here. Like the environment is like purposely preventing you from, like, I don't know, putting an O when there's already an X. I think it'd be
That's
what?
a hard question.
Okay.
Yeah,
I
I
guess
guess think
that's
about that. Doesn't matter for the demonstration.
It doesn't really matter for, yeah, I guess it doesn't really matter for the demonstration, but the way to, I guess it's just important to think about when people are developing this end is like, what is likely to be occurring here? And so like, I was gonna say, yeah, it was like,
3 to 9?
yeah,
That's not correct.
that's not correct. Wait,
No, because
I searched it up. It's 5,478 are the valid states, and 3 to the 9 is the total.
3 to 9 is massive.
3 to the 9 is the maximum possible.
wait, 3 to the 9 is massive, but it's still discrete.
Doesn't matter.
Okay, yeah, it doesn't
It's
matter.
irrelevant.
But regardless, so the state space there is really big, but at the end of the day, it's still discrete, which means you know, you can like technically be able to simulate all of them. And that's what the end is trying to do. Is like there are so many of these states that exist, and like that's what's going to be likely to be generated by the environment. You have to design the environment in such a way that you know it's respecting these edge cases. Okay, so then for the action space. Does anyone have an idea of like what the action space or what an action would be first?
Choosing a spot.
Yeah, exactly. Choosing a spot, and the end would be basically handling the X, like whether you're X or whether you're O. And by that metric, what is the action space?
placing the next
The size of the action space.
3 by
But yeah, you're right.
3 by 3.
Yeah. So it'd just be 9 because you have 9 possible choices. Technically, as the game goes on, you have less and less choices to choose from, and that way, like the way you design the end, which is like your responsibility, is to make sure that you know people aren't overriding certain squares. Okay, so that's a pretty simple example. I think another thing we can do is Google Snake. Like, if we're talking about making a Google Snake loop, the end would be the Google Snake game. What would the state be?
where the snake is and where the apple is.
Exactly. And we can formulate it in multiple different ways. You could represent even tic-tac-toe as text and pass it into the LLM as text. But yeah, you could say, okay, I will only pass it where the snake is or where the apple is as well. Or we can pass in an image, which is the like a screenshot of the board. Our platform will let you do any of that. So all of that is supported. You can pass in an image, you can pass in text, you can pass in like audio, all of that supported. So yeah, that's right. In that case, what do you think the actions are? Yes.
To move left, right, or straight.
Exactly, yeah. So you only have 3 possible actions to move. And so that the size of the action space would be 3. And your end would also, assuming that the LLMs are like bad enough that they are hallucinating certain stuff like going backwards, your end would have to capture that and say that there's an error there. Finally, I guess like we have one other extra like topic, which is the reward. In this case, like the reward is usually generated after like you define that in the environment, which is when the agent successfully completes something. So specifically for the game of Snake, what do you think the reward would be? Yes.
Consuming an apple.
Consuming an apple, yeah. And the way we check whether or not like how much we reward the model is maybe like number of apples. But once again, it's up to you guys to determine what it is. Okay, and I guess like our final example will just be something that like I guess already exists. We're gonna design cursor. So what do you guys think the state of cursor is? This is very open-ended. Like,
Cursor in what sense? You need to clarify that.
oh, okay, like cursor coding, like or using cursor to code.
Like a CLI tool or like a UI?
Wait, does it matter?
It does not, but maybe give them like something to think of.
Okay, well we'll say the UI because I like using UI. Yes. The screenshot?
Yeah.
The screenshot of what?
What's on the UI? I don't know, like your conversations, right? Your chats.
The whole thing.
Yeah. The thing on the UI is your code files, right? Like probably like the files you're trying to modify. So the state actually would be like all of these code files you want to change, and also your prompt, right? So yeah, I guess you're right. You would like pass it. The state would be passed into the LLM would be the code files that you wanted to change and like whatever prompt you wanted to build. And in this case, what do you guys think the action would be? Basically, what the LLM is doing.
Just coming up with a response.
Yes, exactly. Coming up with a response. So generating some text, and this text would then be copied into the file somewhere. Okay, exactly. And this is literally under the hood. If we boil away all the extra stuff happening in the end, this is all Cursor is doing. You give it some model. You give the model some context, right? Like maybe the files you want to change, whatever you wanted fixed, possible tests, and then it generates a bunch of text, and then it gets passed in there. And in this case, the state space is actually infinite because the model could generate a lot of random stuff. It could give you like a story about ponies or something that isn't like related at all. So in this case, the action space is continuous, and the reward is actually something very hard. Like it's something that is very complex to verify. Like just from the start, you would need like a human to say, okay, I like this code snippet that was generated. This code snippet is correct. Yada yada. And so yeah, I guess like with that in mind, this is how we kind of want you guys to think when you're designing the end. The actual coding of this will not be very hard. Making the environment loop, like that's not the complex part of this. What we want you to do is like think about the types of environments that could be created, the edge cases involved with like creating that environment, and thinking about how to make sure that like your system prompt when you send it to the LLM is accurate enough that it's not going to generate a bunch of garbage. We're letting you guys we're benching you guys with the best like models on the market right now. So GPT 5.5, Claude Opus 4.7. Yeah, we're using Claude Opus 4.7 because I'm paying for it, and also Gemini, which is paid for by Squid, I think, or it's like free or whatever. And so yeah, we're gonna be using the best models so that like it's most likely not gonna generate any like garbage output, but if it does, like if your environment is so hard that like it literally cannot, like it gives an action that's completely out of the action space that you guys are imagining, that's fully possible. I guess that would be considered a failed benchmark, and I guess you would have found something that all the top labs right now have not like solved, or that would be a good environment, unless like your environment is like generating garbage or something. But yeah, other than that, that's all there is for the interactive demo. Oh yes.
So are we just graded on like the completeness and complexity of the environment?
Yeah, like we're not gonna go and look at your code base and be like, wow, this code is like garbage or something. But what it is, like, what will be graded is like, is this environment actually, you know, like, is it actually like interactable with the LLM for one thing? Like, it's not giving the LLM like random like stuff. The second thing is like the idea behind the environment. Is it actually testing something legit from the LLM? If someone is like building some sort of arithmetic LLM, arithmetic environment, which is just like, can an LLM do 1 + 1? That's already a solved problem. So like we already know most of the top models right now can do that. So that would not be something interesting. Like you would not get like brownie points for that basically. But if you were to be like, oh, can these LLMs solve like partial differential equations and be able to like verify those generated answers, that would be something that would be very cool because almost all the top labs right now are trying to find physics PhDs to build those types of environments for them. Does that answer your question?
Yes.
Okay, cool. Yeah.
So, like, for example, like if our environment was like an online tic-tac-toe,
Yeah.
and like to test it, so do we make the code like pop up a browser, or do we have to like replicate the tic-tac-toe in our code, or?
You can design it however you want, but the caveat is that it could be, you could like simulate the browser, you could be making API calls, but at the end of the day, you will have to like upload your code to be run on our platform. So it would have to like make the calls through our platform basically. Yeah.
How will you have the end connect to the LLM?
How will we have the end?
Yeah.
Okay. Great question. I think this might like correlate to your question as well. The way we are benching this so far is basically we basically clone your environment, which is in a GitHub. You have like the specific end files, you have your domain files, all of that. We clone it into our like AWS service, run it in a Docker container. Wait, I know your eyebrow shot up because you're like, wow, that must be a horrible security like issue, right? You're right, it totally is. And we are hoping that you guys are not like making us unzip a 50 gigabyte, data set in our service. Yeah, it's a big issue, and we're hoping you guys don't do that.
Why was the child the attack vector?
Okay, because yesterday when we were beta testing it, some guy like made us download a huge data set and it like fucked up the whole thing. So we had to go fix that. And we're hoping you guys don't make that issue.
If you zip bomb our benchmark, I'm banning you. It's 100%.
Yeah. But that's how like we're gonna interact with your environment. Is that we're gonna download it and then we run our services to interact with it basically. Yeah.
Isn't that why it's sandboxed?
Okay. So what we discovered is that even though it is sandboxed, there are still a lot of issues,
Sandboxing is like a somewhat preventative. They can still, take down the container, for example. If like we had a really big service and we could only take like 50 environments being requested per second, like we had some sort of throughput, and then all 50 that were being zip bombed, even if like technically we have a fleet, right? That's still an outage, it's still a degradation of our service. So yeah, it's subtle. Like I don't think you're not gonna like get into this container and like hack our system like it's some sort of Zuckerberg movie, but you will probably take down environments if you're really malicious.
And also, the sandbox actually, like, it contains multiple environments running at the same time right now because of our compute limits. So,
it's literally a single host. You guys would be unbelievably shocked at how simple it is right now. If we were to continue to scale this project, we make it something better, you're gonna see all the stops being pulled out, auto scaling clusters, etc., where it's just like it can handle any amount feasibly, but it's somewhat broke right now.
But if you guys want to work on fixing the platform, you can join SWEC. This will be through a lot of issues that need to be fixed. Yeah. Is there any other questions? Yes.
So when we're testing, is there a limit to how many times you can use your benchmark software?
Yeah. So our boy Nav, I don't know where he is now. I guess he's like studying for his econ exam. But he built this local hosting that allows you to run Olama locally on your computer to test out the benchmark like before you submit it. There's two processes. So while you're building your environment, you can test your test your environment with like using your own API keys or using the Ollama like installation, and this is all described in the wiki. But when you submit the environment, you have the chance to basically publish it and run benchmarks on our using our platform. In that case, we don't have an explicit limit for what you guys can what you guys have to do or how many times you guys can run that. But we're just hoping everyone is chill and not spamming it. Yeah.
Use the cheap models first, please, too. There's a set of models which you can choose from. Choose the ones that are simplest to run or cheaper first, and then you can choose the ones that are more expensive for like your final runs or the ones that you think are more comprehensive too.
Yeah.
Just testing like our API endpoint, like do we would that submit like the IP of the endpoint or like the localhost IP?
Yeah, I think you would have to do that. If you have issues though, I will be online like for the rest of the night, so I will help you fix it.
Yes, ask any questions. We will actually tech support it. We will literally fix it in 15 minutes if we can.
That'd be good.
Oh, he had to go.